Okay, here's the second installment of indirect proofs. And this one is a little bit more complicated, but still very manageable. So hopefully, since this is the third one we've done, you'll start to feel a little bit more comfortable. So I've drawn a picture here of a triangle, and I have said that the given is that angle A is obtuse. So this angle right here is obtuse. And we want to prove that triangle ABC is not a right triangle. Okay, that's what we're being asked to prove, that ABC is not a right triangle. So let's make our chart. We have our statement side and we have our reason side. And then we are going to start, as always, with our given. So we're going to say that we have triangle ABC, that's given, we can see it right there. And we know that angle A is obtuse. That's what's given. Okay, so our second step is going to be our amazingly awesome new step, which is an assumption step. We are going to assume that triangle ABC is a right triangle. And the reason that we put there is the beginning of an indirect proof. So hopefully you're starting to get very comfortable with this idea. We have an assumption that is false, an assumption that is the opposite of what we're trying to prove. And then our reason for that is, hey, we're starting an indirect proof. I know that's a crazy thing to say, but we're saying it because it's an indirect proof. Okay, so that's kind of like a standard for indirect proofs. Okay, so then our third statement is going to be something about an obtuse angle, maybe, or something that's about a right triangle. Let's go with the obtuse angle. So I'll say that the measurement of angle A is greater than 90 degrees. Measurement of angle A is greater than 90 degrees. And my reason here, can you think of the reason? It's the definition of an obtuse angle. Okay? We have written in our notes that an obtuse angle is one with a measurement of greater than 90 degrees. So that's what I've done there. Okay, so I know that this angle right here is greater than 90 degrees. All right, so my fourth step, I'm going to say that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. And the reason I can say that is because we have a theorem that says that the sum of the angles in a triangle equals 180 degrees. Right? So, ta-da! All right, so that means that the measure of angle B plus the measure of angle C has to be less than 90 degrees. And I can say that because of algebra. Right? So I know that all three of them together have to equal 180. I know that A is bigger than 90. So I know that B and C together have to be less than 90, right? Because we're only going up to 180. That's the algebra. All right, well now I have come into my contradiction. Because I cannot say that the, wait, I'll make one more. I'll say that there is an angle in triangle ABC that equals 90 degrees. There is an angle in ABC that equals 90 degrees. And that is the definition of a right triangle, right? Now I have my contradiction. Now I say that there is a contradiction between step 6 and 5, right? 6 says that there has to be an angle that equals 90 degrees, but 5 says that if you add them both together, you're less than 90 degrees. Oh boy, those two things cannot happen together at the same time, at least not in this universe. So contradiction between step 6 and 7, so the assumption in step 2 is false. The assumption in step 2 is false, which means that I can say triangle ABC is not a right triangle. The opposite of this up here now goes down here. All right, so that is a kind of a longer version of an indirect proof. Again, when Fred has you do indirect proofs, usually he gives you 90% of it and then you're just filling in 1 or 2 things. So please don't be frightened about indirect proofs. You will get a lot of practice and you will also get a lot of help. All right, I hope you found this interesting.